So good afternoon, everybody, and welcome to our session number 2 of network security from scratch, right? So yesterday we talked about that why we should learn network security, and then we talk about confidentiality, right? So in continuation with that, in today's session, we are going to complete the confidentiality part first, right? We talked about symmetric encryption. We talk about what is the meaning of algorithm and the key. Now, in today's session, we are going to finish confidentiality portion, and then we are going to start integrity. Okay. So if I remind you, then the approach is going to be same, right? If I say we have done confidentiality, so security was a big puzzle, right? And if I say we are done with the confidentiality, then you should make your mind believe that at least 25% of the security is done, right? Believe me, when we are done with all these 4 subtopics or the sub puzzles, you can say, right? When we combine them, we have a solid understanding of networking basics, and then when we combine them, it is going to result into TLS or IPsec. We are going to see that. So to begin with, we are going to complete our asymmetric key encryption. Then we talk about integrity. It is going to take some time. There are multiple boards on this topic. And then we are going to talk about one simple network attack, through which what I want to do is I want to make sure that you understand how an attacker thinks, what is the mindset, and then how a particular attack can be prevented. Okay, so we are going to discuss today a very common attack which is happening. That is an Icmb flood attack, and believe me, it is going to be very simple to understand. And if you understand an attack, you can straight away prevent it. Okay. Last thing, we are going to talk about authentication if time permits. And in most of my sessions, if I write this sentence, if time permits, generally time doesn't permit. Okay, so possibly we are going to cover these 3 things. We are going to understand confidentiality, integrity, and then a special type of attack, which is denial of service, which we are going to talk about. Okay, so having said that, let's move to our first board, which is confidentiality, right? In yesterday's session, we talked about that if there are 2 parties, and 2 parties were Anjali and Rahul, right? If they want to send a message, then they should have at least one key, and we call that key as a shared key. We didn't talk about how this key is going to be exchanged over internet, over an unsecure medium, right? But we simply talked about that, presume that these both parties, means Anjali and Rahul, have this key shared, and because the intruder wasn't having that key, and that is why he was not able to decrypt the message. The meaning of key was simple. If you compare it with daily life, you have a document, right? And you have a lock. You have this key, you lock this document with this lock, with the key, and at the receiver end, Rahul is going to open this document or this lock with this key. It is as simple as that, right? So now what is the catch here? We were able to get the confidentiality if we have this one key. Then why I'm talking about another type of encryption, which is asymmetric. And this type of encryption was known as symmetric encryption, which was pretty simple, right? We have one key as a source. We have another key at the destination. It was so simple. But now let's talk about what we can do more here, right? Suppose we have Anjali here. We have Anjali's laptop here. No problems. Now what I can do is on this laptop, I can generate 2 numbers, number 1 and number 2. And believe me, these numbers are not random. These numbers are interrelated with each other. I am generating these numbers with an algorithm. Maybe the algorithm name is say algo1. I will let you know what is the algo name actually is. But for now, just try to understand what Miss Anjali is trying to do. She is running an algorithm on her laptop and she generated two numbers. And I'm saying these two numbers are interrelated with each other. But how these two numbers are interrelated with each other? Right? Suppose I have another document. I have one document. Here is my document or my file. That is again my plain text also. I think you understand the meaning of plain text now. Plain text means anybody can read this document because it is in plain, right? So what you are doing is you are encrypting this document using an algorithm, suppose say AES, Advanced Encryption Standard, and you are encrypting this document with this number N1. It is as simple as that, right? You have key, instead of using the secret key, you are using this number now. Very, very simple. What is the advantage? Leave the advantage first. Let's talk about why we are having these two numbers. The importance of this number is if I am encrypting this document with this number N1, I can only decrypt it using its corresponding number. The number corresponding to N1 was N2. These number comes in pairs. So N1 and N2 was a part of pair. If I am encrypting this number, if I am encrypting this document with number N1, I can only decrypt it using N2, which is a part of the pair, right? Even, I am again repeating this thing. If I encrypt with N1, I can only decrypt with N2, even not with N1. I cannot decrypt this document with N1. This document can be decrypted only with the corresponding number. Just try to understand this, right? Similarly, this is the vice versa also. If I am encrypting a number with N2, it is going to be decrypted using N1. It is as simple as that, right? Just wait a minute, guys. Okay, it will go away. So, two numbers N1 and N2, and I am saying N1 is my key, which is denoted by this green color. N2 is my key, which is denoted by red color here, right? And I'm giving them a name now. N1 is given a name as public key, N2 is given a name as private key, and these two numbers are interrelated with each other, that if I encrypt a document with public key, I can only decrypt it with only and only private key, and that is the case, right? But you must be thinking, why, man, why we are doing this? We are a pretty straightforward form of encryption. Just have one key, encrypt the document, share this key with Rahul, and you call it end of the day, right? That is what should be happen, right? But why you are increasing complexity? Believe me, it is going to be useful. It is going to be useful in so many cases. And this concept, public key and private keys, are going to be there in these complete sessions. Means whatever we are going to have, maybe 12, 16, I do not know how many. But all these concepts related to public key and private key are going to be there with you. So please pay close attention here. We are talking about two numbers which are interrelated with each other. They are interrelated, and such that if I encrypt a number with a public key, if I encrypt a document with public key, I can only open it with private key, and the vice versa also, right? Now, let's try to understand why we are doing this. Why two keys instead of one? Let's see that. So here we have another board. The diagram is, the picture is little bit same. We have Anjali and now we have Rahul also. They both have their computers. And now, just wait a minute, guys. Ashish, can you confirm? Am I audible? Because there was a disturbance in the sound.
Yeah, Vishnu, you're audible.
Perfect. So we have Anjali, we have Rahul here, and we have their laptops or the computers, right? Now what we are doing here is Mr. Rahul is generating two numbers. He's generating two numbers, K3 and K4. K3 is going to be Rahul's public key and K4 is going to be Rahul's private key. Now, what is these names suggest? What is the meaning of public and private? The meaning of public, as name suggests, is it is available to anybody on the internet, right? Because it is public. And what is the meaning of private? As the name indicates, private should remains with you. So you are generating two numbers, one public, one private, which are interrelated to each other. But at the end of the day, K3 or the public is going to be everywhere and K4 is going to be. So I made a mistake here, guys. Just reverse this. K3 is my private key because the diagram is according to this. K3 is my private key, K4 is my public key. The concept is going to be same. Public means it is distributed everywhere. So it means that Rahul, which is having this K4, this key is available to Miss Anjali here. How it is going to be available to Miss Anjali? We haven't talked about it, but we are going to talk about it. Do not worry about it, right? So here Mr. Intruder is there and this intruder is also going to get K4. Why K4? Because it is publicly available, because it's a public key. Now, what trick Anjali is doing here? Just try to understand. She has a piece of a paper. She has a plain text where it is written, "Hi there, how are you? Enjoying learning security?" Absolutely. We are enjoying learning security. Now, what Anjali's trick is, because she has Rahul's public key, which is K4, which is this blue one, right? What she is doing, she is using an algorithm, suppose AES, and then this key value, and then she is getting the encrypted content, and now this encrypted content is going over internet. As simple as that, right? We will talk about this intruder first, but let's try to understand. Suppose we do not have any intruder in the picture. So what is going to happen? This encrypted text is going to be reached at Rahul, and what Rahul is going to do, because Rahul has, and only Rahul is having the corresponding private key, which is K3, right? He can open this document. He can decrypt this document using the same algorithm, because Anjali have already told Rahul that she is going to use AES as an algorithm. Now Rahul is going to use its side of the key, which is private key, right? And then he can open the document. The trick here is Anjali is using Rahul's public key to encrypt the document so that Rahul can open the document with its own private key. And that is where these two numbers are interrelated, right? This key 4, which is the public, the key 3, which is private, these two numbers were interrelated and was generated by this computer. How these numbers were generated, I'm repeating once again, how these numbers are interrelated. If anything which is encrypted with K4 can only be decrypted using K3, and vice versa also. I haven't given the example of vice versa. I'm just encrypting a document with the destination public key, and he is going to open its own private key. And because only Rahul has this key, which key? Key number 3, which is the private key, right? Only Rahul can open this document and nobody else. Now let's introduce this intruder in the picture. What this intruder can do? This intruder can take this piece of paper, which is an encrypted document, right? This document was encrypted via Rahul's public key, which is K4. Now to open this document, intruder is going to need K3 value, which is Rahul's private key, which it doesn't have, although he has the public key of Rahul. But he cannot open this document with the public key of Rahul, only with the private key. It is as simple as that. Now, it is pretty interesting. Again, the question which is coming into your mind is, why we are introducing complexity? Why two keys? We can do the same thing with symmetric key encryption on where there was only one key. But try to understand the logic first here. We will make sure that you understand where we use a asymmetric key and where we use symmetric key. But understanding of both the concepts are going to be important. And what we are learning as overall here is we are learning confidentiality. What is confidentiality? Confidentiality is the process of encryption of a particular message so that only sender and receiver can open it. The data is going to be confidential between the sender and the receiver. No intruder can take the data, right? So that can be achievable using secret key or symmetric encryption, and that can be usable using asymmetric key. It is as simple as that, right? So till now, what we have discussed, if I again draw that complete security picture, we have divided it into 4 pieces. We just completed confidentiality, and now we are moving to integrity. So now 25% is done, guy. I'm not saying you have learned 25% of the overall security. I'm just saying the fundamentals of the security, you are good with 25% of the part, right? Now, let's talk about integrity, where it is coming into picture. So we are moving to our next board here. Here you go. Now this Mr. Intruder is very annoyed with Anjali's trick. Previously, he was able to read the messages because the messages were going in plain text. Now Anjali is encrypting those messages, right? Very simple. Now Anjali is encrypting those messages and Mr. Intruder is not going to capture them because he cannot decrypt it, because he doesn't have the secret key or the private key. If we are doing symmetric encryption, he does not have the secret key. If we are doing public or asymmetric encryption, he doesn't have the private key, and that is why he's not able to. So he was pretty annoyed. What he is doing now, what he's thinking now, that although I cannot read the message, but I can alter the message. If I cannot read it, I'll make sure Mr. Rahul also cannot read it. I will just tweak the message. I can just forge the message. So he is pretty annoyed. So what's going on now? Mr. Intruder cannot read the message, but how he can forge? Just take an example. Miss Anjali is having a plain text document which she is using AES as an encryption algorithm, and she is using a key value which this guy doesn't have, and sending the document which is encrypted. Let me make this document encrypted, right? This document is the encrypted document. It reached to Mr. Intruder. Mr. Intruder is saying, okay, I don't understand what you have written here, but I will take this document, right? And I will write something else on it, maybe with different color, right? So if he can do that, then what is going to happen? Mr. Rahul is going to get a message which is completely changed, which was not sent by Rahul. It means that intruder took the message, although it was an encrypted message. But if Mr. Intruder can took this message, he can forge it, he can put anything, and then Mr. Rahul is doing as usual thing. He is going to receive this document. As simple as that, and he will do the decryption part using AES and same key value. But you know what? He is not going to get the meaningful information, and then he is annoyed on Anjali that what you have sent me, I cannot read. Then Anjali is saying, you should be, because I am encrypting with my correct key, so you should get the meaningful information. But Rahul is saying, no, I cannot read anything. It's a problem. And why it's a problem? Because intruder has changed the content, and if you change the content, Mr. Rahul is just doing the same thing. He is just using the same algorithm, the same key, and here is the problem. Rahul cannot read it. It means that Mr. Intruder's efforts in destroying the communication between Anjali and Rahul, he is absolutely successful, right? So what we need here, what we exactly need here, we need that Mr. Rahul should come to know that whether this message is actually from Anjali or not, right? Or whether somebody has changed this message or not in the middle, in the transit. And if somebody has changed this message, then Mr. Rahul should know about it. And if he knows about it, he can simply discard this message. It is as simple as that, right? The message will come, Mr. Rahul will come to know, okay, this was not the message sent by Anjali, but he has some mechanism for that. He should have some mechanism for that. And what are those mechanisms? We are going to learn about it, okay? So as I mentioned in most of my session, that it is always good if you compare the concepts with real lives. If you do, those concepts are going to be with you for longer period of time, right? Let's talk about that how integrity is achieved in normal life. Suppose we have Anjali here, right? And we have Anjali's fingerprint here. What is the relationship between Anjali and her fingerprint? The relationship is that basically no two humans in this complete world have the same fingerprint. It is known. It is a known fact. Although we haven't checked it, but yes, it is a fact that a person can be identified using his or her fingerprints. We all know about it, right? And that is why what we used to do is, if we have a document, say it's an important document, and everybody wants proof that this document belongs to Anjali or this document is signed by Anjali, what we need to do is, we need to make sure that we put Anjali's thumbprint on it or fingerprint on it. It is everywhere, right? So anybody who can see the document, right? They can see the document and they can match Anjali's fingerprint with this document. If this matches, then basically this document was signed by the Anjali, right? So there is a one-to-one relationship between Anjali and this signature, or basically this thumbprint. Only Anjali can have this thumbprint, right? We all know about it. Now let's compare. Can we have something like this in mathematics also? Can we have something like this in digital communication also? It can be. Suppose if I have a value, if I have a plain text, right? And if I can generate a number from this plain text which belongs to only and only this plain text, right? So this is the number, this is just like a fingerprint of what? This document. If I change any content, if I add, delete or remove anything out of this document, this number is going to be changed for sure, right? Similarly, if I change Anjali to some other person, then of course that person is not going to have the same fingerprint like Anjali. Similarly, this number which is coming here is the fingerprint of this document. And how we are going to achieve it? There is a mathematics behind it. The mathematics is that we can always have one-way functions. What is the meaning of one-way function? The meaning of one-way function is, if you provide it any input, it is going to provide you an output, but in only one direction. It is not the case that if you provide the same function as output, it is going to give you input. So it means that with this number, it is almost impossible. It is impossible to calculate the complete text, but other way around is always possible, right? So if somebody changes, this number is going to be changed. But if somebody doesn't, means if no one change it, and if we know this function, suppose we know this function, it doesn't matter in which part of the world we have, If we have this function and if we have this document, the number it is going to be calculated is absolutely this one. And that is why if I can attach this number with this document, it is as good as, although there are some differences, it is as good as this document with the fingerprint. We have this document with the number, because this number is the fingerprint of this digital fingerprint of whatever we have here, right? But now it is very, very important to understand this function which we are talking about. I am not going deeper into the mathematics. You are all free to go and learn, absolutely, right? But we are going to talk about this function which is one way, and we call them hash functions because they are producing a result which is a hash value. Let's talk about it. Let's talk, but have one picture in your mind what problem we are going to solve. We are going to solve a problem in which this intruder was here, right? Although he cannot read the messages, but he can change those messages, right? And what we want is Mr. Rahul should come to know that this message is actually from an intruder who has changed it. And if he comes to know, he is going to discard it, absolutely. No doubt about it, right? Now, let's talk about this hashing function or this that how we are going to achieve this. So suppose Anjali is having this plain text. And now one more thing, guys. We are reading all these concepts separately. I mean, we have just finished confidentiality. We are learning integrity, right? So now let's leave confidentiality part. Now just put all of our concentration on integrity. We are not here to make sure that message is confidential. We are here to learn how you are going to provide integrity. What is the meaning of integrity? The meaning is the message should go intact without any forgery over the internet. It is as simple as that. How we are going to maintain this integrity, we are not talking about confidentiality, so do not get confused. Integrity with confidentiality. But yes, we are going to combine them together at the end of maybe third session. But right now, just leave about anything, whatever you have learned in confidentiality. You have learned, that is fine. Now we are making just our close attention towards integrity. Now we have this plain text and we have this one-way hash function which is producing this result. And believe me, again I'm repeating, doesn't matter where you are. You are in India, or you are in USA. If you are in USA, if I give you the same file, which file? The plain text file and this one-way hash function, it is always going to give me the same result, which is 101011. It doesn't matter wherever you are. But if anybody in the middle, if anybody can change this A to W or something, they can change how are you? Maybe they can change this T to W. So it will become hi there to hi where. But believe me, this shortest, even this short change is going to change this number drastically. This number is always going to be a fixed output. Maybe this hash function is going to produce, suppose, an output of 20 digits, suppose. So it doesn't matter how much longer file you are going to have, your output is going to be always 20 digit. If somebody has changed this file, these 20 digits are going to be changed. It is not the fact that if you change one digit here or one alphabet here, it is going to be changed one here. No, it is not one-to-one relationship. Even if you change, even if you put a dot here somewhere or full stop here, this is going to entirely change this number. It means that there is no one-to-one relationship in terms of whatever the output is, right? But you cannot get this message back from this number. It is always going to be one way, right? But let's see how this hash function is going to be important for us, right? You must be thinking that this guy is not taking the break. This guy is not letting us asking the question. But believe me, let me complete the hashing portion. We are going to come up with the question. But in the meantime, please do write your questions and I will ask Ashish to repeat your questions when I take a pause. Okay. Now, let's talk about here the third board, where we're talking about, just leave about these terms, message detection code, everything. Do not worry about it. We are going to read. Now, what Anjali is doing is we are talking about integrity, not confidentiality. So you are going to see all the messages in plain text. Okay. Because we are solving slightly different problem. We are solving a problem in this message is not forged. Anjali is here. Anjali is having this document, which is the plain text document, simple. And she is passing this document through a hash function. Maybe suppose this hash function name is MD5. It could be anything, algo1, algo2 or MD5. But the important thing is this is a hash function, one-way function. It is going to give you one result, one number. I'm just saying, just leave this intruder part for now. We will come back to it, but for now let's assume on internet we do not have any intruder. So what Anjali is doing, he is passing this document to hash function. It is generating this hash value or the number, and she is appending this document and this number. It is as simple as that. Now this complete document is going over the internet, and Mr. Rahul is just making them separate. Rahul knows where is my message. Rahul knows where is my authentication part, this hashing part or the number. What Mr. Rahul is doing here, just pay a close attention here. Mr. Rahul is again passing this number to the same hash function. It means that Rahul also knows that Anjali is using MD5. In fact, this intruder also knows that Anjali is using MD5. This is good, right? Rahul is passing this same message in this MD5, right? Hash function. He is going to get the result. He is going to get the hash value. Now he is going to compare the new hash value, whatever he has configured, whatever he has computed, with the hash value which was attached with this message. If these two are same, then Rahul is absolutely sure that this message is not tweaked with, this message is not forged with. Nobody has forged this message, right? Because this message, anywhere, irrespective of the fact, wherever you are, this message is going to give you the same hash value if you are passing it through the same hash function. As simple as that. If these results are same, it is going to be good. Now, let's talk about Mr. Intruder. What he can do. If he is going to get this message, right? He is going to get this message. He is going to get this hash value also. It is as simple as that. What Mr. Intruder is doing, if we change this message here and send it here, Mr. Rahul going to remove this message from the hash value. Again, is going to pass it to the MD5, and absolutely this time this hash value is not going to match. And if this hash value is not, because you have changed the content of this plain text. If you have changed the context of this plain text, it is going to be a problem. Because these two hash value, the one which Rahul has calculated and the one which came with this message, are not going to meet. And if they are not going to match, we can say this message has been forged. But now, the question is this a foolproof solution? And you must be thinking, and I could see there are a lot of questions, I haven't read them, but I can read some of your mind that you must be thinking that what this guy is telling. Mr. Intruder now also can change this message, right? How? Let's see that. I am thinking Anjali has developed this, that Rahul, I am going to send you like this, but this Mr. Intruder is really sharp, is absolutely a sharp guy. What actually he is doing is, just wait a minute guys. So what this Mr. Intruder can do, right? He is going to get both the things, right? He is going to get the message. He is going to get the hash value. Here is we have hash. So see how intelligent this guy is. His guy ultimate aim is to destroy the communication between Anjali and Rahul. Although Anjali has thought some of the things that through which she can deliver a message safely to Rahul, but Mr. Intruder is at the next level. What exactly he is doing? Just try to understand. He is taking this message, right? He is going to change the message. Now the message is having Mr. Intruder's whatever Mr. Intruder wants to inform, right? And now he has calculated the another hash because he knows that Anjali is using MD5. If Anjali is using MD5, he is going to create the new hash on this tweaked value instead of the original value. Right? Now he is going to have this hash value, which is calculated via MD5 over this tweaked value. It means that this message is going to be here. What Rahul is doing? Rahul is going to separate this message with the hash value, right? He is going to pass it over the MD5, and of course these values are going to be same because Intruder was sharp enough to change the hash also along with the message. And if he does that, Mr. Rahul never come to know about that this message have been changed or not because MD5 hash is matching. Whatever he calculated with the one which he already got with the message, absolutely those are matched. And if those are matched, right? If those are matched, Mr. Rahul is going to think that this message has not been forged. So he is going to believe he is not going to discard that. So what is the solution? So whatever Anjali has proposed in this, whatever we call them, these things are called as message detection code because it is simply saying that Rahul can detect the error in the message or forgery in the message. But believe me, this is not effective. But can we do something to make this effective? Now Anjali is thinking. She is thinking a lot that how we can make this communication successful communication so that Mr. Intruder cannot change it. And that is what I'm going to showcase you on next board. Just try to understand, guys. What Anjali has developed this time, we are using the same codes, which is message detection code. But what exactly going on here is now Anjali is sending this document, hashing it with MD5. Let's say, suppose this time we are going to. So, guys, this is my way to introduce new terms. Previously, we have used MD5, which is an hash algorithm. We can use the same thing here also. Do not get confused. Let's use the same MD5, but we have other form of hashing algorithm like SHA, secure hash algorithm, right? So we still have MD5. We are producing this guy, right? Now Anjali has two things. She has plain text message and she also has this hash value. But what Anjali is doing now is she is sending the hash value over a unsecure medium, which is your internet. Right? And now she is sending the corresponding value into a secure channel. How you are going to make this secure channel, it is a complete different thing. But now Anjali is saying that I want to send this hash value over a different channel and Mr. Intruder cannot access it. And now she is sending the plain text or maybe the encrypted text just like that without any hash value. This is becoming interesting. This guy knows MD5. This guy also knows MD5. So at the end of the day, let's see, first Intruder is not there. This hash value is going to be here. This message is going to be here from the internet. Rahul is doing the same thing. He is doing MD5 hash. He is calculating the value. Both the values matches. This value came from the secure medium, which is corresponding to this passage, right? If these two values are same, Rahul is confident enough that nothing is changed. But now let's introduce the intruder also into picture. The problem is now intruder does not have this hash value, right? And if we change anything in this, right? So now he has two options. He can change it and send it as it is, He can change it and send the MD5 authentication, sorry, MD5 hash value also. Because this message is coming like this, what he's doing is he's happily doing is changing from hi there to hi where, suppose, or anything. If it has changed it and Mr. Rahul got this, what is the difference here? Mr. Rahul is going to pass this message into the same hash algorithm MD5. He is going to get the value, hash value, and definitely this because the message has been changed, this hash value is going to be changed. And if this change, it is not going to match this value. And if it is not matching, then Mr. Rahul is going to be confirmed that this message was not forged anywhere. But now the question arises, you can always say, what Vishnu, if that is the case, send both of these things on the secure channel. Why are you sending this message here and the hash value here? If there is a secure channel, just send everything here. But there is the cost of the secure channel is somewhat more as compared to public internet, right? So although there is a better design, if you have a secure channel, just send everything to there, right? But here our approach is that you understand that there are something which you call message detection code. Those are not useful if you send them everything on the internet, but those can become useful if you send the hash value over a secure channel and the plain text over the internet. So if an plain text or ciphertext, if the intruder change that value, it is going to be change the hash out of it, right? So it is as simple as that. Now let's talk about something which you would like more, and here you go. So now MDC became MAC, which are MAC. It is not the MAC address, guys. This is message authenticating code or authentication codes. What exactly these are? Now, Anjali is continuously thinking about how to make this communication robust, how to achieve this integrity. She just wants that whenever I send something, this guy should not able to change it, and I do not want to use secure medium also. I want to send everything over internet. Can she do that? Yes, because we know the concept of secret key. There is one key which is shared between Mr. Rahul and Anjali, and Mr. Intruder does not have that key. Let's see what Anjali is doing here to make sure that intruder cannot forge this packet. So what she is doing, along with this message, along with the plain text message, she is appending her secret key. So what is going to be the input in the hash function? The input is going to be your message plus the secret key, and secret key is known only and only to you. Nobody else knows about it, right? Except for the Rahul, because it's a shared secret between two, because you two want to communicate, right? Now it is going to calculate the hash function, maybe anything. Maybe we can use SHA here this time, and it is going to provide me the output, right? And believe me, only Anjali, right? If Anjali has its private key, then basically this value is changed, right? Because now the message is changed. Now the message is not only this. We have one extra member here, which is a key. Key is just nothing but a number. If we are concatenating this message with the key, the message is changed, and that is why this value is going to be changed. But how we can utilize it? Let's try to understand this on the next board. It is as simple as that. Now just try to understand. We have the same board. Mr. Intruder is here, Anjali is here, and Rahul is here. But now Anjali is having a secret key which is shared with Rahul. So both have this key, green color. No problem with respect to that. How they have shared, there is an interesting mathematics behind it. We are going to learn it. But for now, just presume both of these parties have the secret key with them. It is as simple as that, right? Now we have a document here. Anjali puts or concatenates or just prepend or append, you can say. There are multiple ways. This key value in this document, now she is using SHA or MD5, doesn't matter. And she is getting this result. I am just leaving intruder from the picture just for now. This message is going to be flowing across internet. This plain message or encrypted message. We are not reading confidentiality, so message can be plain here. But believe me, we are going to combine them. Right now we have this message and this this hash value. The interesting part is Anjali is not sending its secret key along with this message, and why she would be, right? She's just sending the message and the hash value. Both of these things are going to be reached here. Rahul is going to take message away with its hash value because he has the key. Anjali has already informed it that Rahul, now I am calculating the hash value with the message and the secret key. You need to do the same, and that is why this guy is going to do the same. Here we have this message. Here we have this key. Rahul is going to append, prepend, or whatever Anjali is doing, going to pass it the same hash function, which is SHA. It is going to give the same results, right? This result. And if these two values are same, it means that nobody has tweaked this message. But now let's try to understand what is going to happen if this Mr. Intruder is going to get both of these things. What? This message where we have written, hi there, how are you? And along with that, he's going to get the hash value. Pretty interesting, right? Now, what he is doing here, suppose he changed the message. He completely changed this message. Can he calculate the hash value? No, because he does not have secret key. How Anjali have calculated the hash value? Because she has appended her secret key, and now Mr. Intruder does not have the secret key of Anjali. And if he doesn't have, he can calculate the hash value with its own secret key, definitely. But when it is going to be received here, it is not going to match. Rahul is going to take this message. He is appending its secret key and calculating the hash. Hash is not going to be matched if this message is going to be changed. We are not using, guys, any secure communication channel here. We are just including secret key of these guys in the communication, which is not possessed by Mr. Intruder, and that is why he cannot force the message. And if he cannot force the message, Miss Anjali is successful. Now, so you try to understand, there is a continuous race between the guys who wants to secure the network, and then there are guys whose whole sole intent is how to destroy your network, right? So if you are a person who like this competition of mind war, then you are a suitable candidate for learning deeper network security concepts. Pretty easy. Anjali is trying to make sure that this message is not going to be forced by anybody. And Intruder is trying everything to force that message because he cannot read it. Because you are pretty good with the confidentiality part now. I hope till now this is informative. Let me complete the attack portion also, and then I will sit together with you guys for next 15-20 minutes or maybe 30 minutes, unless I cover all of your questions. But most of the things which were coming to your mind while reading about message detection code or authentication code should be gone by now, because we have what we can say. We have talked about almost every scenario, but yes, it is my understanding that we have talked every scenario, but there must be which is something. If something is left, please do ask. Now let's talk about, we are introducing an attack today. right? Just try to understand the mindset of the people, how these people can destroy your network. Suppose here is the network of a company or enterprise for which Anjali is working. And Anjali is also responsible to maintain this network. She's pretty good with that, right? So generally what she does, whenever she wants to make sure that she wants to do some changes on a particular router, she gets logged into that. But before logging into this router, sometimes she wants to do a ping, that whether this router is up and running or not, right? So what is the impact of this ping message? Router has to reply to it. So Anjali is sending ping request and router has to reply. It is as simple as that. But what is the catch here? The catch here is generally router gets two types of packets. One, which are flowing through it, means the destination address or the source address of this packet, whatever is going, does not belong to this router. So means packet is coming, router is checking its destination IP address and it is forwarding it, right? So these are transit messages. No problems, router can forward it. That's not an issue. But now there are some messages which are directed towards this router, and this ping message is one of them, right? Because you are straight away saying, Mr. Router, I am sending you ping request, please do reply. It means that router has to process that message. It means that router has to put its CPU to process that message, and he is going to, or it is going to reply back to you. But in the meantime, he has to put its processor in generating that reply. So Anjali is going to send the ping request message, which is replied by, or we call it as ping echo request, and the reply which it got is ping echo reply, right? And these packets are part of a protocol which is known as Icmb. So guys, if you are not comfortable with that, if you are not comfortable with the networking basics, believe me, I have a complete series which is absolutely from scratch. If you do not know anything about networking, still you can go and learn about it. There I have explained a process that how traceroute work. So that is explained as almost 1.5 hours, where I have talked about Icmb, UDP and so many things, right? So Icmb is a protocol which is having multiple messages, right? And those messages, inside those messages, basically if I talk about, I'm talking about only two, which is ping echo request and ping reply. So if I'm sending a ping request to a router, it is going to reply me back, but that router has to put some CPU because that packet is directed towards itself. It needs to generate the reply message, and that is why CPU is going into that. It is as simple as that, right? But how the simple thing can be converted into an attack, right? So that guy, Mr. Intruder, is again watching it. Okay, although I could not able to read the communication between Anjali and Rahul, and now Anjali is hashing it also, so I cannot change it. So let's try to destroy the network on which Anjali is working. So see the effort of this guy. This guy have a lot of perseverance because he is after them. Now he's after the network of Anjali's enterprise. Let's see how it is going to do some attack on its network, right? Here we have Mr. Intruder. No Anjali is in the picture now. It is all show. This all show belong to Mr. Intruder, what he is doing, right? And see the sophistications of this attack. Mr. Intruder has his machine, right? And believe me, he can control many more machines, or maybe these machines are part of his own network, right? He is whole sole creator of these machines. He have bought all these machines. Or if he's a intruder of the next level, then there are so many attacks which can, and you won't be, for suppose you are wholesale responsible for this laptop or this PC, right? Mr. Intruder, what he can do is he can hack this system and can use this system for its own activities, for its own processing, right? And it doesn't matter where you are, in which part of the world, right? He can take some amount of your processing power in doing his work, and whatever the number of laptops of computers he can operate or can control becomes a botnet. What is the meaning of botnet? The meaning of botnet is Mr. Intruder is so skillful that he has gone and get the access of so many computers around the world, right? And he has created the network out of it, so that whatever he is going to say, that all the computers on my botnet, right, all the computers everywhere, just start sending ping to this guy. Which guy? This router R1. It means that this guy is controlling so many computers of the world. Everybody is going to send the ping message and many ping message towards this router. And if that is the case, the important part is this router has to process the packet because he's need to reply those messages, right? These laptops can be part of, can be owned by Mr. Intruder, or he can be much more sophisticated intruder, so that he can control many laptops around the world and is asking them to send ping message towards this guy, which is routers owned by company of Miss Anjali, right? So many messages. And that is why CPU is going into some unnecessary activities where this router is replying the ping request. And if that is the case, this router is not doing its actual work of just forwarding the packet. Although I can understand there are two different approaches, data plane or the control plane, we can separate it. But now, just try to understand. The point here is to understand the mindset, right? How they can do this. Now router is not doing whatever the service it needs to do. The service was to switch packet between one network to another network. Now router is spending most of its time in replying these messages because these are control messages. And that is why a router is not doing its service, and that is what we call them as a denial of service attack. Right? Router was doing service, but it cannot because of this Mr. Intruder. It is as simple as that. On top of it, whatever the packet, if this router is down, then basically no traffic flow can go from here to here because this router is absolutely doing something else. The solution is very simple. Anjali is smart enough. Anjali can say that, okay, if that is the case, what I can do is I can configure this router to not reply anything. Whenever the ICMP request come, I can guide it that do not reply anything. But is that the solution? No. Because many people can legitimately want to ping it to check whether it's working or not. So the solution is different also, that Anjali can rate limit the request or the reply which this router can send. Maybe only 5 per second or maybe 5 per 10 minutes. Right? So just try to understand what we have learned today is the ICMP flood attack, which comes into the category of denial of service attack. Or if this attack is coming from distributed locations, we call it distributed DOS. Right? Having said that, I would just like to take a pause because last 1 hour I am speaking and speaking. Now it's your time. If you guys have any question, or Ashish, if anybody has any question which you haven't provided answer to, I am open. So just please unmute all of them, guys, and you can ask any questions, whatever is coming to your mind. Am I audible? Ashish?
Yeah, Vishnu, you are audible.
Okay. So can you put everybody on unmute?
Yep.
Or if we have any question, we can talk about it now.
Vishnu.
First name,
Can you hear
please.
me?
Go ahead, name,
My
please.
name is Sushil.
Yes, Sushil, please go ahead.
Hey, Vishnu, my question, I put it on the Q&A space as well. Is encryption only related to confidentiality and hashing is always related to integrity? I mean, can we use these terms interchangeably?
No, no, there are different mechanisms, but believe me, what we have done is till now, we have read confidentiality separately, integrity separately. Just give me daytime. When we combine them, then the picture is going to be clear.
So that is right. You can't use hashing for the encryption, right? That is
Yes,
just to check whether your data is correct or not.
absolutely. You are right, Ashish.
Right, and just a couple of questions. Is Cypher used for, I mean, I'm just going beyond what you would be covering, but if I need to park it for next sessions, that's fine, but I'll just ask the question anyway. Is the Cypher used for hashing only, or is it also used for encryption in TLS handshake?
No,
And
no, no. Hashing means hashing. Encryption is totally different thing. But just give
okay,
it. I'm repeating again. When we are going to discuss TLS in detail, I will exactly show you where we are using hashing and where we are using encryption. Do not worry.
right. So the last question probably also I'll let you know, and probably that can be covered later. Does Cypher name also indicate? Probably you answered. Does it indicate encryption algorithm or just the
Cipher is
hashing algorithm?
basically a suite, right? It contains what exactly you want to do. Means if you want to do encryption, with what methodology you are going to do encryption, with what
Okay.
methodology you want to do the hashing, or basically your
Okay.
key exchange. So it's a group of things. We'll be covering that.
All right.
And
Fantastic. Yeah.
yeah,
Thank you so much.
no problem, Sushi. Anybody else,
Hi,
guys?
Vishnu.
Yeah,
Hi,
Dipanjan here.
Please go
Vishnu.
ahead. Yes,
Yeah,
Dipanjan.
just a layman question. So when we are sending this mail to other client, some other company, it's going through internet, right?
Absolutely.
So, yeah, so is this by default encrypted when you are sending those mails? How it is?
Yes, mail encryption. See, if you are sending another company, it is going over the internet. Yes, it is encrypted. It depends on what exactly you are using. For example, you can create a system where you are part of your own enterprise, right? And the communication is going on between these two guys, right? A and B, which are part of this. You can make them encrypted or you cannot. There are so many mechanisms now in the email client as well as email server, which is responsible for encryption.
Okay.
Although we are not
So
going
by
to cover it, but
default,
yes,
it's
those are encrypted. Yeah, go ahead.
yeah. So sorry, Vishnu, to interrupt. So by default, it is not encrypted. So it depends on IMAP and SMTP servers you are using,
Yeah,
right?
yeah.
So you have to enable the encryption over there, and at that point of time, the mails will be encrypted or it won't be encrypted.
Yeah.
So is there any mechanism in your Outlook or something we can encrypt those messages? Because by default it's not encrypted.
Yeah, there are two mechanisms. First is the SSL encryption, which is used by most of the servers, right? Second mechanism is in Outlook itself, and we mostly use certificate to encrypt that email, right? And that certificate is been provided by the organization CA, right? So that is something different where it is end-to-end encryption from the email which has been sent from one of the person's Outlook to the another person's Outlook, right? And another encryption is between server to server, where the email has been traveling from over the internet or over the server to server.
Perfect.
Yeah, thanks, Ashish.
No problem.
Yeah, hi, Vishnu.
Yeah, please
This
go
is
ahead. Name, please.
so yeah, this is Murli.
Yeah, Murli.
Regarding the integrity
Yeah.
question on the integrity, right? So, say, I mean, you said that the sender is going to create the hash using the message plus the private key.
Yep.
That's going to be the hash, right? So, is there a possibility that, I mean, Mr. Intruder do some reverse engineering and from the hash value he can, and he has the original I mean whatever the message, right? So he can get the private key.
No, it is this
Because the
function.
hash is calculated based on the
I
original
understand.
message
I
plus the
understand
key.
that. But I always say this is the one-way function, right? And this is the this is the capability or ability of this function to to not calculate things on the reverse direction, right? If you can, then basically it is going to be a problem that your system or whatever the mathematical function you are using for calculating your OS is not capable enough, right? So right now, there are some attacks happened recently on these hash values also, right? But those are pretty secure, and that's what that's what we call as that. Suppose if we take an example of SHA, right? SHA 256, it is going to calculate a 256 bit value, but it is almost impossible. Although we have seen some cases in which the different file is going to produce the same result, although pretty means it is rare, absolutely rarest of the rare event. But if it happens within any algorithm, right, that multiple values are producing the same result, the same hash value, then this algorithm is not good in terms of uniqueness of this code, right? So till now, I am absolutely not sure that whether we have done such attacks like that, but to best of my knowledge, this function is irreversible, right? Yes, there are many technologies available, many analysis methods available which this intruder can use, and I'm not denying the fact, because right now, whatever the security mechanism which we have is not possible to break with current computing power, but maybe in the next generation or 10, 12 years, I'm not denying the fact that these can be broken. So, but now be assured that integrity is preserved using this hash, because this message is almost impossible to get. To get the secret key is almost pretty impossible to get from this hash value.
Hello, I Vishnu Rakul here.
Yeah, please go ahead.
When public key and private key regarding this, so for example, now Rahul has a private key and the public key which will be shared, right? So how the Anjali knows the private key, because that generates locally. How can we share that?
No. So there is some gap actually in understanding. See, Anjali, here, let's talk about, there is some gap in understanding. Do not worry about it, but it would be great if you can go through the recording, mostly 10 p.m. or 10:30 p.m. you will be getting it. So we are talking about this asymmetric encryption right here, right? So just try to understand, Anjali's any key is not required. Anjali K1 and K2 I am not using at all. I am just presuming the fact that Mr. Rahul's public key, which is K4, is available to Anjali, and it is available. How it is available, it is totally different fact, but because the name suggests it's public, so it is everywhere. So I'm using Rahul's public key to encrypt and Rahul's private key to decrypt, and Rahul, of course, knows his private key. Am I able to answer your question?
Yeah, but you have said like it can be done as a vice versa, right? So private.
No. Vice versa doesn't mean that. Just try to understand. The meaning is, if you are encrypting with public, you can decrypt it with private.
Okay.
Right? It is not the case that you can decrypt it using public also. No. But if you are encrypting it private, you can open it to public. But here the thing is, Anjali is encrypting with the public. So it can be only and open with the private. Did you get that?
Okay, so she can't encrypt with private key.
Private key encryption.
Very good example.
Yeah.
Sorry.
Yeah, go ahead, Ashish. You go ahead.
So very good example is we have browsers, right? And if you see most of the servers, like if you open any HTTPS website, so for those servers, we have public certificate in our browsers, right? So those are the root public certificates. And the servers which are encrypting that may be using private, keys to encrypt all those. And whenever the traffic is coming to our browser, we are using public certificate to decrypt the traffic. And when we are responding back the traffic, again, we are using the same tunnel, right? Which is going to encrypt the traffic. So we are encrypting with our public root certificate which we have, and then again it is utilized by the servers to decrypt it.
So don't worry about it, certificates and all we will be discussing, but for your question, as Ashish mentioned, if we are encrypting with particular key, it can be decrypted using the corresponding key, and that is it. Not even the same key. Anybody else? Yes, please do ask question.
Yeah, Vishnu. Hi, this is Deepak.
Deepak ji, yes.
Yeah. So I just wanted to confirm if this is in administrator's hand to change the method of hashing at their own level, or it is something that is by default, which is being used.
We will talk about it. How these are exchanged and how these two party come to know that which method to use. Do not worry about it. Just
Yeah, because
we will be getting it. No worries. In the next session, whenever we start discussing SSL, I'll straight away tell you that how these guys come to know and when these things or keys get changed. Do not worry.
Okay. So another thing I wanted to confirm, you mentioned if we are using private key and the hashing method. You use the same shared key. Is there any possibility that it can be used with the asymmetric encryption method along with the hashing, or just the symmetric method can be used only?
No. There are multiple methods of doing hashing, right? When we talk about certificates, how we are going to sign it, when we talk about digital certificates, I'll let you know. I was just giving a simple example that if you include your secret, including in the algorithm itself, right, along with the plain text, then it is going to be foolproof. Then it's going to create the MAC, which is message authenticating code or authentication code. But in case of digital signature and everything else, believe me, we are going to talk about it, that how we can utilize these two keys also in case of asymmetric encryption. Okay.
Just a real life example, if you are taking an example of WhatsApp, I believe the scenario that you shared today regarding the public and private key I'm just getting a confirmation from you. Are we using the same concept, public and private key, using when we see
to begin with the communication? Yes, but at the end of the day, it is going to be secret key. That is why we have two methods. We begin the communication with the symmetric so that we can exchange the key, and then we use the symmetric. But those are the things which require some more time, more understanding, and as we have started absolutely from scratch. So till now, if you are comfortable with only the concept itself, do you understand confidentiality? You understand integrity? That is what I needed. But believe me, we are going to cover all the things. Okay.
Yeah, Vishnu, just to add, I think it's a very interesting question you asked.
Yeah.
You asked regarding the WhatsApp, right?
Yeah.
So WhatsApp, we are not using any public keys. The reason is that is end-to-end encryption. Why I'm telling you that, if you are sending me a message, right, and if someone else is having the same public key, he might or she might be able to decrypt that traffic and would be able to see that message, right?
Yeah.
So it's not exactly public key, but yeah. So in that case, it's a reverse, encryptions are used. So another person won't be able to see that traffic. So it's an end-to-end encryption, not a public to private encryption.
Okay. So that altogether is a different algorithm and procedure that is being used.
That is right.
One more thing on top of it, Ashish. Whatever we are reading here in terms of confidentiality, integrity, and authentication, right? Or as mentioned by Ashish, that we are going to use a simple secret key in WhatsApp communication. But believe me, how do you come across that key? It is a very important parameter. So at the end of the day, the concepts, whatever we are learning, and we can take an example that actually how WhatsApp encryption is happening. We'll let you know. Do not worry. But till now, the fact is that we understood confidentiality and integrity. Yeah, we are going to combine it for the security, full security. Go ahead, guys. Anybody else? The questions?
Yeah, Vishnu, this is Shubhadeep.
Yes, Shubhadeep.
Yeah, my question is, let's say Anjali is sending the content and the message with algo plus now the K4. So I think both are some mathematical functions and the format of the output will be same, right?
Yeah.
Now, if the intruder manages to change the message in such a way that the when Rahul wants to decrypt it, is it possible that the key will corrupt or gets corrupted?
You are not sending key anywhere. You are not sending Yeah, you
I'm
are
saying
sending this
that
message.
if I'm changing, see, a key and the algo are some functions, I believe. My content is
Yes.
passing and it's giving some kind of output,
Yeah.
right? Now, if I change the content in such a way that the algo plus the key will give me a corrupt message or something
Definitely,
void,
and that is where you need to combine this. You are absolutely correct that although this message is not readable at all, and this was the problem of this intruder also, right? He cannot read the message, but he can tweak it, right? And if you can tweak it, then of course whatever you are saying is absolutely correct. Mr. Rao is not going to make any sense out of it. And that is
Okay.
why you need to combine confidentiality with integrity, which we haven't. Even we need to combine authentication also. Believe me, I am repeating once again and again. If this is the complete security solution, we just covered confidentiality separately, integrity separately. We are going to learn authentication maybe tomorrow, non-repudiation maybe day after tomorrow or tomorrow. If we can combine all these things together, then there is a no doubt, no question in terms of what this intruder can do or not. Because as you can see, all the communication, whatever we do from the bank or any from the Google side or anywhere, we are doing right now, right? And it is absolutely secure. It means that whatever we are learning is absolutely secure. But yes, picture is not complete till yet.
Okay. One following question. Like we have this concept CIAN, which is the concepts for the security. So does this also ensures that if a message is changed, we can revert back somehow get the original message as well? Because in that case, let's say someone is checking our data and every time they're changing my message.
I understand.
So
I got the
yeah,
question. I got the question. So actually, this is the intelligence of your application now, right? See, this is the
okay.
application which was created this message. The message was on transit. This guy has changed it. This guy is not able to read it. He is going to drop it. And if we drop it, then basically it is not reached to application number 2, right? And these applications are talking. So it is the intelligence of your application to send this packet again.
Okay.
Okay.
Oh.
Yeah.
Mhm.
Go ahead, guys. Anybody else?
Vishnu Nirajana here.
Yeah, please go ahead, Nirajana.
It's a very silly question if
No,
I
no question is silly. No question is absolutely silly. Please, whatever in your mind, do ask.
So Anjali uses this AES algorithm to generate N1 and N2, basically some K1, K2 keys.
No, not
right?
EAS, not AES. AES to encrypt, right?
AES to encrypt.
Yeah.
And like
Maybe let me take a name of a algorithm which can do that. The name is RSA. So Anjali computer can run this algorithm RSA to calculate these two numbers, N1 and N2, which is your public and private key. Okay.
Okay, so you say that N1 and N2 are interrelated somehow,
Yep,
right?
yep.
Like, is there a possibility that if we know a public key, then from there we can find out the private key?
No. This is the beauty of this algorithm, right? And that is why there is so many mathematics behind it.
Okay.
Although these numbers are interrelated, but in such a way that if you know N1, you cannot calculate N2. Absolutely.
Okay.
Yeah. But question was good, not a silly question. Go ahead. Anybody else? Okay.
Yes, hello.
Yeah. Go ahead, please.
Okay. So we use, in the certificate-based authentication, we use the asymmetric key, correct?
We haven't introduced certificate-based authentication. Just please hold your horses for that. We will be coming into that.
Yeah.
Okay. Certificate we will be explaining in greater detail. Do not worry. Anybody else?
Hi Vishnu, Finance here.
Yeah, please go ahead.
So if the intruder is able to change the content, so what if he is able to, if he is doing that continuously, if Anjali is sending that message 100 times, all the 100 times is able to change the content, then this is also kind of an attack only, right? So how are you going to handle that?
This is the denial of service attack. It can do, but believe me, most of the time, if if somebody who is destroying this communication is not getting anything out of it, right? Although he can destroy the communication, right?
Right.
But if he's not, then most of the time he left that. But you are right. There should be mechanism to stop it, and believe me, it is not as simple as possible to capture those messages out of internet, right? So to answer to that question right now, I do not have any fixed answer for that. But maybe when we complete some more things, then you come to know the importance, or then you come to know what the nitty-gritty is going on, and that can answer. But now I do not have answer for that. I'm sorry for that, but maybe I go and check it. That how to revert that. But it's a very good question actually.
Vishnu, as he mentioned that the intruder can change the message. So when we have the integrity, the intruder will not be able to change the message, right?
No, the integrity means yes, he can change the message always. Doesn't matter. The whole point is whether Rahul comes to know about it or not. Right? Anyhow, he can get the, it doesn't matter whether we have put hash or not, or encryption or not, anything, right? He can always go and change this content, right? But the important part is Rahul should come to know about it, that if it is changed, then basically it's a problem.
Right. Okay.
And that is where basically, maybe the one answer for the previous question is, that is where this private network comes into picture. For example, WhatsApp has their own network, right?
Right.
But most of the things are again going over the internet. So yes, we are. But if I tell you that how the security overall works, then maybe this question can be answered. But right now, I do not have a very clear answer to the previous question. Yes, if an attacker wants to do this, he can always change the content. Okay, anybody else? Oh, this is good. It means that we have taken all the questions too. So thank you so much, guys. Thank you so much for making this session quite interactive. See you in tomorrow's session, where we talk about authentication. And most importantly, I think we are going to introduce tomorrow certificate authority. Okay, and I will be uploading the video on the YouTube, and that is what you can have a look at it. So 2 sessions are done. We have still lot to cover. See you tomorrow. Thank you so much for being a wonderful audience. Bye for now.
Thanks everyone. Have a great day. Bye.